All right, this is 11.4 part 2. It's pretty short. This kind of whole chapter is on the short side. So we're describing the shape formed by the intersection of the plane of the solid. So we are identifying cross sections. So first we're going to identify the solid shape and then kind of the two-dimensional shape that happens when it's cut. So again, based on the base, this is a prism. And specifically, this is a hexagonal prism. And they cut parallel with that base. Here's the cross section. So our two-dimensional shape is a hexagon. So our three-dimensional shape is a hexagonal prism. Our two-dimensional shape is a hexagon. Here, this is a pyramid. We base it on the bottom. So the bottom is a triangle. So our three-dimensional shape is a triangular pyramid. And our two-dimensional shape is a triangle. Here we have a cylinder. Now, if they had cut the cylinder horizontally, it would have created a circle, but they actually cut it vertically, which creates a rectangle. Here we have a cone. Our cone is our three-dimensional solid. And that two-dimensional cross-section is a circle. Here we have a sphere. And no matter what angle you cut a sphere, it could be just a tiny bit off the edge, it could be straight down the middle, it could be horizontal, it could be vertical. Your two-dimensional shape for a sphere will always be a perfect circle. For a cone, if it had done it at an angle, you'd make an oval. Same thing for the cylinder. But a sphere, you are always going to get a circle. And here, it looks like our solid is a cube. And then our cross section, it kind of went in at an angle. It's actually a trapezoid. It's definitely a quadrilateral, but it's a trapezoid. The last part of this chapter, section rather, is solids of revolution. I'm going to include some videos that kind of show these different things because it is a very visual thing. So look at that in the links on Final Site. So here we have solids of revolution, which essentially is if I was to take a shape like this rectangle and if I was to spin it. So let's say I have this square that I've put on this axis of revolution. If I was to spin it, what kind of shape does it create? So a solid of revolution is a solid created by rotating a two-dimensional shape around an axis of revolution. And that axis of revolution becomes the center of that 3D shape, or of that solid. So here I have this this rectangle. Here's the axis of revolution. And if I spin that, you can kind of see it's creating this solid, and eventually it creates a cylinder. So for another example, let's say here's my axis of revolution, and it's a triangle like that. Well, if I spin it, it would actually kind of become a top. So, see here, I want to sketch the solid produced by rotating the figure around the given axis, and then identify and describe the solid. So, when we rotate a rectangle like this, we get a cylinder. And what I mean describe is kind of include these units. So, this stays 9, kind of the height. It's the height because if you had looked at it like this, it would be the height. Then here, this is 4. 4 becomes the radius of that circle because if you were to spin it, the diameter would be 8. So if you're trying to see where the axis of revolution is, it's right here. Here we have a triangle as a base of 2 and a height of 5. So if I was to rotate that, I would get a cone. I kind of get this cone shape. The height inside is going to be 5. And that's actually where the axis is. And then the radius is going to be 2 of that base as a circle. So that is the end of 11.4, and you can get started on your homework.